Hello, geometry students. Welcome back to your last lesson of the year. If you finished everything. If you're all caught up with us, hopefully you are. Hopefully you've been working this whole time. If you haven't, make sure you're talking with me so that we can guarantee you get fourth quarter credit. But if you've been keeping up with us, then yay, this is your last lesson. And after this, it's just the test, the IXLs to complete. So yay, we're making it this far. Alrighty. Today's Flipgrid question of the day is up there. Go do it. It's good fun. You've already found the YouTube lesson if you're here. Now, pause the video, try that problem in your notes, and then unpause it to do it with me. We are asked to find the volume of a pyramid, and we know that the volume of a pyramid is 1/3 base times height, where B is the area of the base. The base of this pyramid is a square. We can tell by these tick marks. These tick marks right here tell us that every single side is the same. So the area of the base is just base times height, or side squared, because it is a square, and we get 10 times 10, which is 100 centimeters squared, because we're talking about area. So when we take our volume, the area of the base is 100, and our height is 12. So we're going to take 100 times 12 divided by 3. This is equal to 400 centimeters cubed, because we're talking about volume, and volume is 3-dimensional. So there you have it. 400 centimeters cubed. Not so bad. Not so bad at all. Okay. Today, it's another twofer. Another 2-for-1. We're going to learn about 7.8 and, 11.7 and 11.8 in one day today. 11.7 is about cones, and 11.8 is about spheres. So first, we'll talk about cones, and second, we'll talk about spheres. So the essential question for each of them is, how can you find the surface area and the volume? How can you find the surface area and the volume? So our learning target is that you know what cones and spheres are. Maybe you already know that, maybe you don't. Our success criteria is that you can find the surface area and volume. Surface area and volume of cones and spheres. So, you know what volume is. Do you know what surface area is? I don't know. We'll have to find out. Okay, so first, 11.7, cones, surface area and volume of cones. What on earth is a cone? A cone is a solid that has one circular base and one vertex. So you can see that this is a circle, it is a circular base, and remember, a vertex is kind of like a corner. So basically, there's a circle on one side, and the other side isn't a side, it's just a point. So, yeah, you don't have to write this down if you already know what a cone was, but if you didn't, please write it down. Make sure that there's a picture in your notes at least, so that you know what they look like. Okay, so 11.7, the first thing we're talking about is all about cones. So make sure that you know what one is. This is important information. Pause this video, write this down. Surface area of a right cone. Remember, and right cone means that it's perfectly straight up and down. We're not talking about these cones. Not for surface area, we are not talking about these cones. What is surface area? So remember volume. If I take my I'll take my box example. Let's call it a fish tank. A fish tank. So, volume was, if we poured water into this fish tank, how much water would it take to completely fill up the fish tank? That's volume. Surface area is if I paint the outside of this fish tank. So I paint this side red. I also paint the back red. I paint the sides yellow, I paint this side yellow, and then I paint the top green and I paint the bottom green. If I paint this whole thing, if I paint all 6 sides of this fish tank, how much paint am I using? So if I were to wrap it in wrapping paper, if I'm wrapping a box with wrapping paper, how much paper is it going to take to cover this entire box? So surface area is the outside. It's just the outside of a shape. So surface area is 2-dimensional because we're just talking about one flat surface. Whereas volume is I'm filling up a 3-dimensional object. There's a really cool problem involving surface area and volume. There's a really cool problem involving surface area and volume called Gabriel's horn. Fascinating. Fascinating, fascinating. Finite volume, infinite surface area. How is it possible? How is it possible? Yes. So, check that out if you're interested in it. Maybe I'll put some links in the description for fun videos about it, because boy is it cool. Anywho, back to the surface area of a right cone. This is the surface area of a right cone. Do I expect you to memorize this? No. No, I don't. Is it difficult to memorize? No. No, it is not. So, if you want to memorize it, all the power to you. It'll help you on the standardized tests we have to take next year and the SAT and things like that. It'll help you with. For my tests, again, we're just doing IXL, but even if we were in person, I'm not going to make you memorize this. I'll put it on the board for you. But it's a good exercise to have it memorized. So do what you want with this, but make sure that it is in your notes so that you know what it is. The surface area of a right cone is, hey, that looks familiar, pi r squared. That's the area of a circle, and that's because our base is a circle. So this part of our formula is the bottom of the cone right here. And this pi RL is the surface area of the rest of the cone up here. All the way around. All the way around the cone. So, yes, surface area pi r squared plus pi RL. Where r is the radius, now let's get this out of the way. R is the radius, just like usual, and L is what's called the slant height. So it's not the vertical height. It's not this. It's actually the slant height. You want it to be the slanty side and not up and down. So that is something different than what we've seen before. Alright, let's do an example of this. Surface area of right cones. Remember, surface area is equal to pi r squared plus pi RL. And now, we just plug in our numbers. So here is the radius. Whoa, no. Here is the radius. Here is the slant height. So now, pi times 4 squared plus pi times 4 times 6. So remember, you can keep this in exact form or you can put it in approximate form. Of course I'm going to show you both because IXL might want one versus the other and I want to make sure you know how to do this. So 4 squared is 16. We have 16 pi plus 4 times 6 is 24. So this is 24 pi. 16 plus 24 is 40. So this is 40 pi units. Inches squared, cubed, what? Remember, this is surface area, which is just 2-dimensional. So that's our exact form, because we have 40 pi, and pi is irrational, so we would have a crazy decimal. But if I do 40 times pi, I will get my approximate answer with the giant decimal, which is approximately 125.7 inches squared. Don't forget your approximate equal sign, your squiggly equal sign that says approximate. Remember, both of these are correct. This is exact form, and this is approximate form. Alright, there you have it. Not so bad. Not so bad at all. Let's see if we were right. Booyah. Square inches. Booyah. Okay. Next, cruising right along, we're talking about surface area and volume. So we talked about surface area, and now we're talking about volume. The volume of a cone is very similar to the volume of a prism. Or excuse me, of a pyramid. 1/3 base times height, but remember our base is always a circle. So it is 1/3 pi r squared h. This also reminds me of a cylinder. Remember, pi r squared h was the volume of a cylinder. So it's like 1/3 the volume of a cylinder. Interesting, interesting. Yes, so notice that now we can also talk about slanty cones. Remember, when we talked about surface area, we could not talk about these, but now that we're talking about volume, we can, because Cavalari's principle still applies here. The base is the same, and the height is the same, and the cross-sectional area at each level is the same. So, 1/3 pi r squared h, 1/3 the volume of a cylinder. Make sure that you have written this down. If you haven't, pause it, write it down, and then we'll move on. So finding the volume of a cone, remember, volume is 1/3 pi r squared h. And now we're just plugging stuff in. There's your radius, there's your height. So 1/3 pi 2.2 squared times 4.5. And remember, I want this in exact form. So I'm going to do 2.2 squared times 4.5 divided by 3. And this is 7.26 pi. Units. Centimeters squared, cubed, volume. Volume, so centimeters cubed. Alright, remember that was exact form. Now we're putting it in approximate form. 7.26 times pi gives us approximately 22.8 centimeters. Remember, both of these are correct. We just have exact and approximate. I don't care which one you put on your homework. I do not care. Remember that IXL is probably, maybe, going to want the exact answer. But the approximate answer is more helpful for you, because what on earth does 7.26 pi cubic centimeters look like? I don't know. I don't know. But I do know what 22.8 cubic centimeters. Okay. Moving on. Oh, let's check if we were right. 22.81 cubic centimeters. Booyah. Awesome. We talked about surface area and volume for cones. Now, let's move on to spheres. Ooh. Surface area and volume. So we have 2 more examples, 2 more things to talk about, and then you're on to your homework. A sphere. Now, you might know of a sphere as just a circular 3D object, but a sphere has a more technical definition. It is the set of all points in space that are the same distance from a point called the center. So remember when we talked about circles, a circle is just the set of all points that are the exact same distance away from the center. And the same thing is with a sphere, only now we're taking that circle and we're going in 3 dimensions with it. So we're kind of just taking that circle and flipping it all the way around. Just like if the Earth were a perfect sphere, everybody standing on the surface of the Earth would be the exact same distance away from the center. Of course, the Earth is not a perfect, but you get what I mean. So no need to write this down if you already knew what it was, but if you didn't know what a sphere was, please write it down. So yeah, center, radius, 2 most important components of a sphere. Alright, let's move on to the, to the surface area of a sphere. The surface area of a sphere is 4 pi r squared. So it's like the area, it's like 4. So remember that pi r squared is the area of a circle, and now we're just taking 4 of those. If you've ever played baseball, oh gosh, I'm butchering this. You've seen this pattern on baseball. So this wraps around and then this wraps around, and you have these kind of patterns on the surface of your baseball. So you can see how there's 1, 2, 3, 4 circles within this pattern. 4 times the area of a circle. There's a much better explanation than that in our textbook. So if you want that explanation, go check out the textbook. But I want to keep this video short for the people that just worked on. So 4 times the area of a circle. That is the surface area of a sphere. Please put this entire box in your notes, and then we can move on to our examples. Find the surface area of the sphere. So remember that the area of a sphere is 4 times pi r squared. So I take 4 times pi r squared. Look at that. 8 is our radius. So 4 times pi times 8 squared. So again, we're going to do exact form and then we'll do approximate. So 4 times 8 squared is 256 pi units. Inches squared, because we're talking about area, surface area. And now let's do our approximate answer. And in fact, you don't need to write exact and approximate. You don't need to write that, because these equal signs tell us. If you write an equal sign, you are saying exactly equal to. And if you say the squiggly equal sign, you are saying approximate. So you don't need to write down exact or approximate. I will know just by looking at your equal sign. Okay, so 256 times pi is approximately 804.2 inches squared. And remember, either one of these answers works. These are the same. Just one is exact and one is approximate. So they're not exactly the same. I'm glad you laughed. Thank you for laughing. Alright, different color. So, surface area is still equal to 4 pi r squared. But what is this? Oh my goodness, they didn't give me the radius. They gave me the circumference. Okay, well that's okay, because remember, I know that the circumference is equal to pi times the diameter, and I know that the diameter is just 2 of the radiuses. So I know the circumference is just 2 radiuses times pi. Which means, so if I have 12 pi, the circumference is 12 pi. 12 pi equals 2r pi. The pi's go away. 12 equals 2r. Divide by 2 on both sides. The radius has to be 6. Because if I take the radius and I double it to get the diameter, I have 12. And 12 times pi gives me the circumference. So, my radius is 6, and now I can just put it in here. 4 pi times 6 squared. And let's do the exact answer. So 4 times 6 squared is 144 pi units. Feet squared, or approximately 452.4 feet squared. Ta-da! So this one we had to do some back solving to find the radius. Do not use this as your radius, because it's not the radius, it's the circumference. So work your way backwards to figure out what the radius is given the circumference. If this moved a little too fast for you, watch it again, or you can go back to our video on 11.1 and 11.2 where we talked about circumference and area of circles. Okay, let's check our answer. 804 inches squared, beautiful, and 452.4 feet squared. Booyah. Okay. Last thing, we talked about the surface area of spheres. Now we need to talk about the volume of spheres. So, the volume of a sphere is right there. I hope you see these problems go pretty quick, because it's just using formulas. This is not my favorite part of math, and I don't want you to get confused that, oh wow, math is just taking formulas and plugging in numbers. Like, no, math is a lot more than that. Math is about how to use these formulas and knowing when to apply these formulas. So please don't think like, wow, math is so boring. I just take numbers and I plug them into formulas. We're doing the boring part because I don't want to overwhelm you with information during this whole crazy COVID thing. But math can be much more exciting than this, and maybe if I have time I'll make some YouTube videos about it. So, this is the important thing to remember. The volume of a sphere is 4/3 pi r cubed. 4/3 pi r cubed. Again, do I expect you to memorize this? No. But is it difficult to memorize? No. You could memorize it. Yes, where r is the radius of the sphere, of course. So make sure you've written that down. And then let's move on to our last example. Find the volume of a sphere. Remember, the volume of a sphere is 4/3 pi r cubed. And we are given our radius right here. So we have 4/3 pi 4.5 cubed. So we'll do 4.5 cubed, and then we'll multiply that by 4. 91.1 times 4, and then is that divisible by 3? It is divisible by 3. Beautiful. So I just multiplied. I took this, multiplied it by 4, divided it by 3, and we get 121.5 pi. Now, is this perfectly exact? No, because there's still a decimal in there. I mean, technically it is still perfectly exact because we have all of the decimal places available. But if IXL asks you for an exact answer, it does not want to see any decimal. So what you will need to do is reduce this fraction, which is very ugly when there are decimals involved. So I'm not going to show an example of that, but if you run into it and you're like, what? I don't remember how to reduce fractions. Maybe I'll put a link in the description to reduce fractions as well as Gabriel's horn. But hopefully you remember how to do it. But I'm making a note to put it in the link in the description just in case. Alright, so we have this. Units, though. We need our units. Inches cubed, because we're finding volume, and that is 3-dimensional. Alright, and our approximate answer, of course, which I'm going to write over here, is 121.5 times pi, which is approximately 381.7 inches cubed. Ta-da! Alrighty. There you have it. Let's check our answers. 381.7 cubic inches. Booyah! Booyah! Oh, we forgot how could I forget to draw the smiley? Okay. This is Bill, and Bill's confused. Don't be like Bill. Ask questions. I am here. I am happy to help. One thing that I want to encourage you to do, when I was in high school, the minute I got stuck, I was like, teacher, I'm stuck, I don't know, I don't understand. And I should have thought for myself a little bit more before just running to the teacher. I was just like, I don't get it, I'm stuck, it didn't work, I tried it once and it didn't work. Like, take a deep breath, try it again, try to problem solve what's going wrong with your own problem instead of just running to the teacher really quick first. Not that anybody's been doing that, but just some food for thought. Just some food for thought. Something that I wish I had done. I would have been a better mathematician if I had problem solved through my own issues before just running to my professor. So, don't be like Bill. Work through your confusion, and if you can't work through your confusion, ask questions. I am here and I'm so very happy to help. This is me. I'm very happy to help. Very happy to help you. Okay. Here is your homework for today. It is Yeah, I know it looks like a lot, but remember how fast some of these problems went. I mean, surface area of a sphere, 4 pi r squared, boom, 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 like, so, yeah. So here's your homework. You have some about cones and some about spheres. You have a lot of bonus questions as well. You have 1, 2, 3, 4, 5, 6, 7, 8 bonus questions yet again. So you could get +8 on your homework. How swell would that be? Would be swell. Yes, and then here is your lunch for today. Comes from Reese Witherspoon. With the right kind of coaching and determination, you can accomplish anything. I like this quote. I like this quote a lot because with the right kind of coaching and determination. So just because you have the right coaching, if you don't have determination, coach can't do it for you. You won't be able to accomplish it if your coach is doing everything for you. So I like that they partner determination with the right kind of coaching. Because also, sometimes, no matter how hard you try, no matter how much determination you have, sometimes you need a coach there to help you. Like me, for example, I love math, but if I were to try to learn PhD level math without, like, a professor or something there to help me, I don't know if I could do it. I don't know. I might need the right kind of coach. We'll have to see when I start trying PhD level math. But yes, so if you're really determined to do something, find a coach that you trust to help you get there. And if you have a coach, get the determination to listen to them and do what they're encouraging you to do, because coaches are there to help you reach your goals, just like teachers. We can give you the right kind of coaching, but you have to have the determination to get the work done and to take your learning into your own hands. So, yes, that is my launch for you. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.